Right. So let us continue with lecture 10. So as I mentioned just now, I won't be doing this example because it is similar to what we have done yesterday on the properties of time shifting or shifting properties, and also properties of scaling, right? So, and also on linearity. So this won't be covered. Okay, and as I mentioned just now, this is a sample of test 2, yeah, which is covering the topics of Fourier transform and also Laplace transform, yeah, chapter 3 and chapter 4. Okay, so I'm going to skip this, but if you can do this example on your own, and if you find any difficulties of solving this or you want to confirm your answer, so you can just inform me. You can just PM me later on, yeah. Okay, let us proceed with this example here. We are having a systems in this example where we have two inputs of the system, which are the EJ5T and E negative J5T. Okay, the signals are said to be added and it produces AT signal. AT will be mixed. Okay, the mixer basically is a multiplier, yeah, it's a multiplier. So when we see this sign, basically this is a multiplication, yeah, multiplication between two signals. So in this case, this is multiplication between AT signal and 4, a constant, and this produce a BT. Okay, and a BT will be mixed or multiplied with exponential J of 2T and will produce a CT. So CT will pass through a system of HT, and this will further produce a signals of DT. Okay, so this is how the system is all about. Okay, right. Let's have a solution for this. Let's have a look at a solution for this example. Okay, we need to obtain three Fourier transform values. The first one is A omega, which is a Fourier transform of AT. Then we have the B omega, which is a Fourier transform of BT. And then C omega, which is a Fourier transform of CT. And second question is that we need to sketch the spectrum for these three signals here, yeah, A omega, B omega, and C omega. Okay, so let's have a look at the solution to this example. Okay. Right, so okay, this is the one, the solution for this example is here. Okay, right, so if we base on the questions, we can say that the AT basically is a summation of two signals here, which is EJ5T and exponential negative J5T. Okay, and due to multiplication between AT and a constant of 4, we're going to have the BT. So BT is 4 of AT, we're going to have this. And finally, the CT, which is a multiplication between the BT and exponential of J to T, we're going to have these signals here, yeah? Right. So if you refer back to the question, the first is to find out what should be the Fourier transform for these three signals, AT, BT, and CT. So I think it's a straightforward question because we can straight away refer to the table. Okay, to the table. Let's say if we refer to this table here, the attachment table. Okay, we note that we have signals of exponential, yeah? Exponential of J omega naught T, this is the one. Yeah, this is on page 2. So when we have exponential terms of J omega naught T, we are supposed to get the Fourier transform of this, which is 2 pi delta omega minus omega naught. So we're going to use this transformation of exponential complex term. Okay, so based on that, by referring to these questions again, we're going to have that the A omega supposedly will give us 2 pi of delta omega minus 5 and 2 pi of delta omega plus 5. All right, so this is based on this AT, yeah? So you can refer to this table in page 2, yeah? So by having that transformation, you are supposed to get this A omega. And same things happen to the BT, which will give us the B omega. So the difference will be only be on the amplitude, yeah? So we have 4 here, so that will be straight away multiplied with 4. So the omega multiplied with 4, we're going to have 8 pi of those values. And finally, for the third equation on CT, we are supposed to get this. C omega will give us 8 pi of delta omega minus 7 and then 8 pi delta omega plus 3 according to this time domain signal. Yeah. Okay, so that should be your transformation, full transformation for both for the AT, BT, and CT. Right. Now the second question is to find out the spectrum of these three Fourier transform equations. So again, it is straightforward because from this answer, the spectrum basically is an impulse. It's an impulses. Yeah, it's impulse. So we're going to have for A omega, simply going to have 2 pi amplitude and 2 impulses at -5 and +5. Also for the B omega, based on the equations here, going to have the same position of the impulses, but the amplitude will be different, which is 8 pi now. And again, for the C omega, we're going to have again 2 impulses, but the position has been shifted a bit, which will be at -3 and +7 with the amplitude of 8 pi. So this is the spectrum for these particular signals of AT, BT, and CT, which subsequently produce the Fourier transform of A omega, B omega, and the C omega. Okay. All right. Is there any question on this example so far? No? Okay. Basically straightforward questions. Yeah. So again, this is also a sample of, if I'm not mistaken, also a test 2 question. Yeah. Test 2 questions. Right. So basically you have to understand very well on the Fourier transform properties, and you must be able to choose appropriate signal based on the given table. So that are the skills, that are the things that I want you to actually know, yeah, so far. Okay, that's all for lecture 10. Okay, so we have done lecture 10, which is basically we have covered few properties up to the modulation, starting from linearity. We have done the time scaling, we have time shifting, and finally we have properties of frequency shifting and modulation. Right. So in lecture 11, after this, we are going to continue with another properties, which include convolution. Then we have also the differentiation and also integration. And also, I think the last one should be on, I forgot already. So going to see after this. Yeah. Okay. Let me proceed with lecture 11 now. Yeah.